Right, so in this video we're going to look at some of Newton's laws with a view to eventually getting into momentum. You need to understand these ideas to get the fundamentals that take you into momentum. So we'll start very quickly. Newton's first law: body remains a constant state of motion or at rest unless acted upon by a external resultant force. So that's what we covered in the forces video. So if we've got a ball with two forces that are, for all intents and purposes, balanced. That doesn't look good, does it? Let's try that again. For all intents and purposes, balanced. Okay, so those arrows are the same size. Then we would expect zero acceleration. Okay, because there's no external resultant force in any direction. Obviously, if I then increase one of the forces, then I don't have zero acceleration. I've got a resultant force in that direction, and that is going to lead to an acceleration in that direction. So now that's pretty fundamental. There's nothing too strenuous about that, and you shouldn't have too much trouble with that at all. But when we look at Newton's third law, what we need to be aware of is that the fact that Newton's third law is that when two objects interact, they exert an equal and opposite force on each other. Okay, so equal and opposite forces. Now, so for example, if we look at a person pushing against a wall, so we had a person here pushing against a wall. The push that you put against that wall is the same as the wall pushing back on you. Now, you might be thinking, well, how can the wall be pushing back? Well, it is, and it has to be, because you don't go through the wall unless it's not a very strong wall, or unless the wall is able to move. So you're not going to go through the wall, and essentially what we're going to get here is a situation where it's stationary. Okay, so stationary, because the forces are balanced. Now, if I push harder, so if I push with more, then the wall pushes back with more too. Now, if we look at this on the fundamental level as to why this occurs, it occurs because one of the fundamental forces that causes interactions of these type. So what's happening here is electromagnetic. So all of your molecules contain atoms which have negative charges around them. So we've got all our negative charges all the way around in like a cloud, and that's the one that's in your hand. And then you've got exactly the same thing, which is all those electrons around the atoms and the molecules and atoms of of the wall. So what obviously happens there is you've got that situation where you've got your hands got lots of negative charge, the wall's got lots of negative charge, and so as a result we'd expect them to repel, as you would expect. So as a result you get that repulsion. We get the wall pushing on the hand, and we get the hand pushing on the wall with the same equal and opposite force, and that's electromagnetic in origin. But that's not the only one that you can have. So you have lots of fundamental forces. So you've got gravitational, and you've got obviously electromagnetic, and you've got two nuclear forces. You've got weak and you've got strong nuclear forces. Okay, now the weak and strong nuclear forces you're not going to be dealing with for a while, so you don't need to worry too much. You just need to be aware of them at this point in time. You should be very happy with gravitational and electromagnetic. Shouldn't really be any problems with that at all. Right, so Newton's third law brings to light this idea of what we like to call an interaction pair. Now, interaction pairs are very important because that is the basis from which Newton's third law comes from, is that an interaction pair can only be two objects, okay? So this is probably where one of the biggest misconceptions comes in, is that you must have two objects, and the origin of the force must be the same, so same origin of force. Now, essentially what you need to realise there is that there are lots of ways of thinking about this. You have to have two different objects, and you have to have the same origin of force, and that works with the wall. Okay, same origin of force, both electromagnetic, two objects, the wall and the hand. Okay, so we've fulfilled that's an interaction pair, equal and opposite force. Common misconception is when you deal with a say an object on a road. For example, you could have like a vehicle. That's normally what they use because that's normally what's on roads. Apologies for my vehicle, but you get the idea. And a lot of times it's suggested that the contact reaction force between so you've got a contact force with the road and the vehicle pushing upwards, and then you've got the weight acting directly downwards. And it's suggested because these forces must be balanced that this is an interaction pair. Well, that is wrong. Wrong indeed. Okay. Well, think about that very carefully. The first criteria of two objects, well, no, you've got that both of these forces are acting on the object. The weight is acting on the object, and the contact force with the ground is acting on the same object. So we've not got two objects here. So that's wrong. Same origin of force. Well, if you look at this force here, that's the weight. Well, that's gravitational. And then we've got a contact force there. Well, that is the electromagnetic. And so as a result, this cannot be an interaction pair. Now that's very, very important that you remember that an interaction pair must be on two different objects and be the same origin of the force. Okay, that has to be the case.